Okay, now in this tutorial, we will cover how to profile your NeuroMechFly simulation, namely how to understand which part of the simulation is taking a lot of time. We'll start by profiling your simulation on the CPU. If you have cloned the FlyGym repository, you'll find in the scripts folder replay behavior CPU and replay behavior GPU. Essentially, these are the same behavior replay task from the previous tutorials, but now, let's say, integrated as a single script that you can simply run. You can run the simulations outside of a Jupyter notebook and save the output data to a certain folder. Right? Here you will see basically the same joint angle visualization, observation data over time, post over time, and the replay video all in this folder. And if you want to profile the performance of it, without any external tool, you can already use Mujoko's internal profiling tool by adding this flag to the end of the script. And very nicely, Mujoko will tell you that, for example, you're spending this many milliseconds in total, or this many microseconds per step, computing the positions of different vertices on your meshes. And this amount of time is spent on collision detection, so on and so forth. Now, if we do use an external tool, namely iSpy, a profiler for Python program, you can get this kind of result. So right. So yeah, so now you'll find this new file, speedscope.json, which contains more detailed information on not just Mujoko, but everything that has happened during this simulation. So I'm actually running this on a remote workstation. So let me start by copying it to my local computer. And the nice thing about it is that you can go to this website called Speedscope. Speedscope.app, which helps visualize the data that has been recorded. So simply by dragging it into this browser, you can see something like this. It happened over the course of 2 or maybe 3 seconds. You can zoom into a small, maybe 0.1 second-ish window and see what's taking the simulation time. So for example, here you'll see that's in set actuation input, it took 2 milliseconds followed by step, but within step you have the different steps solving for kinematics, etc., constraints, and then you have this render as needed function. Right? Typically, probably it doesn't render anything, or maybe in this case it did. But in most cases, when you call render as needed, depending on whether that frame is actually should actually be rendered, it probably doesn't do much. Similarly, when you call get joint angles, you can see how much time it's taking and just this kind of information. The thing that is really useful is that, let's say, if in my simulation I'm also doing something else, for example, let's say my simulation within the loop here, let's say for some reason I decided to create 1,000 Python lists within each iteration. Say that empty list. And we run this again. That's not inefficient enough. We create 1,000 lists of 1,000 elements just to emulate something that might be not so efficient in our code. Okay, that's too much. We don't have time for that. And once again, we can put this in this visualizer. And now you can see that you have these steps, but also after steps, there's a bunch of weird stuff. That's probably our list creation and copying things. That's taking a lot of time. If you go to this left heavy part, it's going to show you exactly which part of it. Like instead of sorted sequentially over time, it's going to tell you like this much time, 5 seconds is spent doing this thing. Of course, here it's not very informative because it's just memory addresses for the lines of code. But if we, let's say, define a efficient stuff, which is doing happy, it's going to tell you that out of your not even 7 second simulation, you waste all your time on this. So in summary, the MuJoCo native timing is very good at telling you which part of the physics simulation is taking a lot of time. MuJoCo is super optimized. It's probably not doing something ridiculous like the thing that we are doing. The profiling tool with PySpy tells you what kind of operation from your own code outside of MuJoCo calls is taking a lot of time. So it's more useful for spotting inefficiencies from your own code. We can do something similar with the GPU, very similar script. Again, you don't have to do profiling. You can just run this quickly to generate to replicate the tutorials, the earlier tutorials. But let's say you do want to profile something, you can run a script like this. Maybe while it runs, I can move on and explain that to view the GPU profiling output, we actually need to use this NVIDIA Insight system. And because it is a GUI, I'm actually just using this remote desktop to view it. Okay, so the result has been saved to FlyGym outputs GPU profile. Okay, so FlyGym outputs GPU profile. You can drag and drop this file into the Insight viewer and see what's happening, right? So probably during those 8 seconds, it's doing some setup steps, and those 10 seconds, it's actually running the simulation. Okay. Yes. And you can see things like, okay, now there's a graph launch that's taking some time, and then there's more presumably computation where where you have different lower level GPU operations. Now, of course, it's a little bit harder to interpret GPU computation, especially if we're doing a graph capture, but at least you can see that there's a lot of time spent launching the CUDA graph, and then there's some time spent copying things probably related to copying the target joint positions. And I mean, you can dig deeper, but this is the kind of things that you can get out of this kind of profiling. Okay, that's all. I hope this has been helpful. If you have any questions, feel free to leave an issue under the issues page, or post a thread on the discussion board. Thank you.